Welcome students. This is the exercise 2.2 for class 10th, and I have uploaded one video in which I had given you concept regarding zeros of polynomial. Although there is always a relation between zeros of polynomial even of any degree, but we are studying here polynomial of 2 degree. Although I would also give you overview for higher degree polynomial at the last of the chapter. So what was the result if alpha and beta are zeros of any polynomial? So if alpha and beta, so we are asked three things. First thing, what is polynomial? I am not asking the definition of polynomial. If alpha and beta are given as roots, then how can you find the polynomial? Second, sum of roots. Third, product of root. You need to understand these three things. And if we assume ax square plus bx plus c, this is the required polynomial. And alpha and beta are the roots of this polynomial. This is the required polynomial, and sum of the root is alpha plus beta, and product of the root is alpha into beta. So since alpha and beta are the roots of this equation, and this is the equation for which alpha beta are the roots, so there should be relation between alpha and beta and this polynomial. So what is the relation? So that relation was given like this: sum of roots minus x plus product of roots we have studied this equation in previous video, where sum of the roots is what? Sum of the roots is alpha plus beta x, and product of the root is, we know these are the roots, so product simply. Now if we compare this equation and this equation, we come to know that if we compare this equation, we come to know that this equation and this equation, these are the same polynomial. So we come to know that alpha plus beta, let us assume minus sign, we are comparing the coefficient only, is equal to b by a. And alpha, how much? C by a. You need to know this thing. We have, and some of you say why I have taken a here. So for this equation, that's why I am putting a there. But this is the equation, and if I told you in previous video, k can be taken as constant. You can understand in coming classes. And if we make the coefficient of x squares, if we take the coefficient of x1 like this, then you can see, because this a which is taken as a common doesn't show any effect on the root. That's why it can be done, and you can understand if you see logically, because this is the ratio. This is the ratio. A is multiplied with this, a is multiplied with this, so it will be cancelled out. So this is the little bit concept. Now I am directly will proceed with exercise. I hope you can see question in the book. So I have also bought new book, Menace book. So far I didn't got books, so I bought the books. I bought the book for you people. Now our question is this. The question is this: find the zero of the following quadratic polynomial. Question is this: find the zero of the following quadratic polynomial and verify the relationship between the zeros and the coefficient. So we need to find out zeros. Let us write the question. So this is the first question. Find the zeros of the following quadratic polynomial and verify the relationship between zeros and the coefficient. Quadratic polynomial. This is the question for you, and we need to proceed this question. Please read question carefully and try to solve. So I think you have tried the question yourself by pausing the video, and if you know the solution, you can use the method of fast and forwarding. Otherwise, see, find the zero. So solution, our equation is given like this. We will split its middle term, and I think you all know how to split the middle term. Take x common, x minus 4, 2 common, x minus 4. So 0 of the given polynomial, therefore you can write 0 of given polynomials are, you can write alpha. Always use alpha and beta. You have to change the names. You have to, how? This is the factor, and when you put x minus 0, this implies that x equal to 4 is 0. Similarly, when you put x plus 2 equal to 0, then x minus 2 is 0. Now we have calculated the roots over here. 0 question half is completed. After that, verify the relationship between zeros, and we know the relation. We know what we know. Alpha plus beta is equal to what? Minus b by a. Now LHS, alpha is 4, beta is minus 2. 4 plus minus 2 comes 2. RHS minus what is B? So that for this you can how can you find out A, B, C? For that you have to compare this equation with which equation? Ax square plus bx plus c. On comparing you will get A is 1, B is minus 2, while C is minus 8. And you have to do this equation, this step over here. Okay, now put minus 2 and A is 1. That comes out to be 2. Since now, therefore, we can say this implies that LHS equal to RHS. First equation is verified. We can write, if you have written this, one is verified. ये verified हो गया है, और no need to write here, you can write directly. Second is alpha beta is equal to C by A. Then LHS 4 into minus 2. 4 into minus 2, that equals to the minus 8, while RHS C is minus 8 and pi A is 1, that is minus 8. Again LHS equal to RHS. So no need to write again and again. You skip this step over here. You directly write, hence verified. You directly write this. You can write we know this and this. We know this first, this second, and फिर आप इसको समझते हैं. So please pause the video and note it down. So please, one thing is, if you find some problem, some mistake in these videos, so please make me confirm so that I can make correction, and I can cut that part and delete the video over YouTube, as I don't have time to recheck this videos time and again. Okay, we will proceed with second question. Second question. 4s this. Now you know x is variable. Ax square plus bx plus c. A, B, C are constant. A, B, C are constant. Can be replaced by any constant. Similarly, x is replaced by any variable. Like this, if I have provided you question x a square plus y a plus c, and I write x y z are constant while a is variable. So question is wrong? No, question is not wrong. We have changed the values, so don't worry if question comes in any other format. So here variable is s. Variable is s. Let we compare the equation with a x square plus bx plus c, or you can also make this equation like this: a s square plus b s plus c. I have replaced this. While comparing, here is minus, here is plus. So what you do, you have to make little arrangement in this equation. You will take out plus sign here and take minus inside. Now here on comparing coefficients क्या मिला? A equals to 4, B equals to minus 4 and C is equal to 1. You can see. Let alpha and beta are zeros. So we have to verify alpha plus beta equals to minus b by a, and alpha beta is equal to c by a. We need to verify if alpha and beta are the zeros, and this, and what are the alpha and beta. For that we have to split the equation by middle term splitting. We can find out the alpha and beta. So for alpha beta, what we contain, we again take the, and we know which equation is this. This is of the form 2s minus 1 का whole square, and this can be written as 2s minus 1. So what we can say, when we put s, when we put here in case, when you can write this equation in this form. Roots are same. When such things is a square minus 2ab plus b square. Let us see. A square minus 2 into 2s into 1 plus 1 square. So you can write this. So this can be written as this. So what are the roots? Roots are s equal to 1 by 2 s equal to 1 by 2. Roots are same. It means therefore alpha beta is equal to 1 by 2. Now verification of this is 1 and this is 2. Verification for 1 LHS alpha plus beta. We will add alpha plus beta, that is 1. RHS minus B. B is minus 4 divided by 4. What is the answer? Answer is again 1. Therefore, LHS is equal to RHS. For second, it is raining outside. That's why I'm feeling some problem. But let me finish this question. After that, I have to post this video, and I will make it again. Okay. So for second, LHS alpha into beta, half into half, that is 1 by 4, and RHS is C by A. C is, where is C? C is 1 and A is 4. This is like that. LHS equal to RHS. Hence, verified. Okay. Hope I will solve remaining question in next video, because it is raining outside. Hope you are liking this video. Keep smiling, keep staying at home, be the part of Corona.